Hello, I'm Paul Beckwith, and in this video, I'm going to talk all about a new report that has just come out from the World Meteorological Organization, the WMO, and they're basically saying that the world is likely to breach 1.5 Celsius, the climate threshold, by 2027. And that's obviously because of a very large El Nino that is projected to be affecting our climate over the next few years. You know, the El Nino is part of the ENSO cycle, which stands for El Nino Southern Oscillation. We've been in a cooling phase called a La Niña for 3 years, so ocean heat has been increasing and not being released to the atmosphere. So with the El Nino that's coming up, the Pacific Ocean near the equator towards South America is warming very strongly because the cold water is being displaced. So the warm water that has accumulated in the western Pacific Ocean is now sloshing across the Pacific, and it's shallowing. It's coming up to the surface, and then when it hits the surface, of course, all that heat is being released. So I'm going to talk about the WMO report, which just came out a few days ago. WMO also has a State of the Climate report, which I'll probably cover in detail in a separate video. I don't think I've done that yet. And since I live in Canada and we have all of these wildfires ongoing in Alberta, starting in BC, very, very warm spring out there, much warmer than normal, so the wildfire season has got a very, very early start. So I'll talk about how, temperatures in Canada have been in the last, over time. Canada being northern country is warming much faster than the global average. So I'll talk a little bit about that, but mostly my focus is on what's happening on the global level. So let's get right into it. So The Guardian, just a couple days ago, came out with this excellent article. I find The Guardian is the most useful for getting the reality on climate change. Their reporting is excellent. And also, I just want to mention that I've tweeted these things out. So my Twitter handle is at Paul H. Beckwith. So please, if you don't have Twitter, go on and follow me and follow, learn how to use the hashtag so that you can get all of the climate stories. So I've just sent out some information on, what's been happening with these global temperatures, that have been in the news in the last couple of days quite a bit. Okay, so this is the Guardian article. So UN agency, and the WMO is a UN agency. So it says that El Nino and human-induced climate breakdown could combine to push temperatures into uncharted territory. Okay, so basically the breaching of this crucial 1.5 degree threshold, which, it's an important number, 1.5 degrees Celsius, 2 degrees Celsius. Think back to the Paris Climate Agreement, the idea to keep global average temperatures below 2 degrees Celsius with aspiration to keep it below 1.5. And we're blowing past that threshold, even if you take the baseline, which is now being used, in most reports, which is the 1850 to 1900 baseline. So if you take the average temperature between 1850 and 1900, compare temperatures now to then, we're going to breach that 1.5 threshold. Now, you have to remember that the original 2 degrees Celsius threshold number, and then 1.5, IPCC GuardBands, if you like, temperature GuardBands were relative to the pre-industrial revolution, which was 1750. So the temperature difference between the 1750 period and the 1850 to 1900 average, which is the baseline now, is from 0.2 to 0.3 Celsius. So we're already, 1.15 according to the above the baseline, the 1850 to 1900 baseline. So we're pushing, we'd be 1.35 to 1.45 above already using the original 1750 baseline. Okay, so it's important to remember that. But anyway, we're heading into uncharted territory in terms of warming. Okay, so this, now it's interesting in this report, they emphasize in these news articles that it doesn't mean the planet will permanently exceed the 1.5 specified in the Paris Agreement, okay, but it means that we'll breach it on a temporary basis, and then we'll breach it with increasing frequency, and then we'll breach it for good. So I'll show you what I mean by that. Like the highest average in previous years, again, this is all relative to the 1850 to 1900 baseline. The highest average was 1.28 Celsius above pre-industrial levels. And here's where we are. Okay, so here's where we are now. So again, the anomalies are always from 1850 to 1900 in these reports. So this is where we're at right here. This is the temperature from 1920 to present, and you can see the fluctuation here. So there was a strong El Nino year here, in the late 1996, 97, 98, around that time period. Right, that's this guy here. And so after a strong El Nino, the temperature kind of stabilized lower, but it very quickly surpassed the maximum within a few years. So you've got the global warming signal, and you've got the ENSO variability on this. Here's where we were. This was a strong El Nino in 2015, 2016, and there was another El Nino here. So this is the situation that we're at, okay? 1.15 or so. And this is what the projected, what the study over the next 5 years is showing. This is the 5th percentile will stay down here. The 95th percentile will blow past the target and hit 1.75 Celsius above the 1850 to 1900 average. So we got the 95th percentile. So in the middle there is the 1.5 Celsius. Okay, so what this study is showing, and it was just published a few days ago, there's a 2/3 or 66% likelihood of exceeding the 1.5 threshold in at least 1 year between 2023 and 2027. Okay, we've been seeing regional near record temperatures being set in many areas of the world with heat waves. The climate breakdown is accelerating. When you have the El Nino, as I mentioned, for 3 years, it's been in the opposite phase, the cooling phase, La Niña, but now we're heading into this El Nino. So the variation with the ENSO, the El Nino to La Niñas, is plus or minus about 0.2 or 0.3 degrees Celsius. So as the La Niña has ended and a new El Nino is developing as we speak, there's a 98% likelihood that at least one of the next 5 years will be the hottest on record. Okay, so the hottest on record so far is this spike here, in the 2015, 2016 case. So, 98% chance that in the next 5 years we're going to surpass this peak. Okay, that's what that statement says. So these are the temperature anomalies, but look where they take them from. They take the climatological mean, an average over 30 years. So the latest interval that they're using is 1991 to 2020. So that's the 30-year period. They take the averages, and here's what the anomalies are in 2022. So you can still see, significant warming in 2022 on this map. In certain areas in the north, in the south, over Europe, there's been lots of heat waves and drought. Also, in over ocean regions. Okay, so there are some regions that have cooled relative to this average, that, you know, they're expressing some cooling, but the average overall is a warming. And El Niños cost a lot of money, a lot more money than we expect. They cost trillions of dollars. They have far-reaching repercussions for health, food security, water management, and the environment. Of course, the Arctic's warming much faster than the rest of the world. It's impacting global weather systems, right? It disrupts the jet stream, makes it slower, makes it wavier, and that increases the frequency, severity, and duration of extreme weather events. Some of the things with the El Nino in the next few years, there'll probably be less rainfall in the Amazon, so droughts in the Amazon, which is not good because the carbon sink ability drops. Central America, Australia, and Indonesia, less rainfall, drought, heat waves. Particularly bad news for the Amazon because of this cycle of heating and deforestation. It could tip the region from being a rainforest into just being grasslands or savanna-like conditions with the odd tree poking up out of the grasslands. Okay, now the Amazon goes from a carbon sink that captures carbon out of the atmosphere-ocean system to a carbon source which feeds more, more greenhouse gases into the atmosphere system, and is very bad. It causes extreme warming again. So there's supposed to be above rainfall in northern Europe, Alaska, and northern Siberia, or snow in the case of far north regions, and the Sahel, according to this report. So for each year, but from 2023 to 2027, the global near surface temperature is predicted to be between 1.1 and 1.8 above the pre-industrial average, which is again from 1850 to 1900. Okay, so, it's there's another COP going on, United Nations Climate Conference of Parties. 28 is the version this year. It's in Dubai. It's going to, do a global stock take, which is to reassess how far the world is off the goals of the Paris Agreement, and we're very far off track. So, we've lost basically 1.5. Okay, and we're rapidly approaching 2. Okay, so that's the article. Now, there was an article, I want to talk just a minute about Canada, a northern country. What does that global 1.5C increase mean for Canada? And they talk about the WMO report and, sounding the alarm. Canada, like other polar regions, it's warming the fastest of all. Canada's already blown past 1.5 degrees of warming over pre-industrial levels. According to the Environment and Climate Change Canada website, the average annual temperature in Canada rose by 1.9 Celsius from 1948 to 2021. Okay, so northern countries have warmed and already breached, these 1.5 limits. And don't forget that the land is warming about double the rate of the oceans. Regions at high elevation are warming about double that of regions of low elevation. And the Arctic, basically the Arctic, depending on how far up in the Arctic you go, is warming, anywhere from, it's warming like 3, 4, 5 to 7 times, 8 times faster than the global average warming. Okay, now they say that we're not going to, when we first pass 1.5, they're all saying, these articles are all saying that, well, we're not going to stay above 1.5. So what we're going to see, clearly from the graph I showed you, just over here in the first article from the graph I showed you, we're likely to see, fluctuation, but in the next 5 years, we'll see a spike from the El Nino probably past 1.5. But what they're saying is it'll probably drop back below 1.5, maybe for a couple of years. But look, when there's a strong El Nino, right, it did drop back, but within a few years, it was already surpassing the previous peak. Same, it hasn't done it yet here. We've got a peak here, we're due to surpass this peak You know, with a 98% chance in the next 5 years. That's what the study is finding. But you know, and here's a guy downplaying the warming, say we got to keep longer term trends in mind. Year to year, there are very large oscillations. So in order to surpass the 1.5 limit, we have to look at climatological periods, which are 30 years at least. Well, if you look at the, you know, I mean, this sort of thinking is just wrong now. I mean, if you look, look at this, you know, this is 2020. This is 30 years back. So 30 years back, you know, we're getting huge warming, right? I mean, the trend is all the way up. So looking at, you know, the idea of looking at 30-year periods is baloney, you know, with the rate of warming that we're seeing. Okay, so, you know, what are the impacts? You know, we need to start thinking about impacts of 3 degrees above normal for Canadians, right? The impacts, you know, the heat events, more frequent, more extensive, increased loss of glaciers, changes to wildlife habitats and habits of people. You know, rising temperature is blamed for the elevated risk of wildfires. And of course, this is what we're seeing. You know, this is from a few days ago in Drayton Valley, Alberta. Alberta has been hot and dry for the spring, much hotter and drier than normal for a spring. And the wildfires have gone through and caused tremendous numbers of hectares burned. You know, also, you know, you need, you know, Canada's a big country. So if you look at Canada's far north, where the permafrost has been frozen for thousands of years, it's thawing, critical transportation infrastructure is basically having the ground kicked out from under it and tilting and collapsing. It's causing huge disruption. So, you know, the Northwest Territories has implemented a heat warning program to warn of extreme heat in the summer. The province has already warmed between 2 and 4 degrees Celsius since 1950. Okay, so this is a weather station near Fort Simpson, Northwest Territories, almost completely destroyed by a late season wildfire in October of 2022. Okay, so while crossing the global threshold of 1.5 is likely in coming years, it's not a switch where climate goes from comfortable to crisis. You know, we all know that. I mean, you know, it's all becoming a crisis. Nothing's comfortable right now about climate change. You know, we have to reduce greenhouse gas emissions and get to net zero and pull CO2 out of the atmosphere and all of these things. And Canada, once again, is miserably failing its carbon targets. You know, there's no new normal. Okay, we're undergoing a rapid change. We're on the sharp edge of a sharply rising curve, so there's nothing normal. You can't say it's the only new normal is extreme weather events, huge amounts of change, but they're getting worse. They're getting more worse, and you know, the extremes are increasing. They're happening more often, so higher frequency of occurrence. They're lasting longer, the duration's lasting longer, and so on. And they're happening in regions they never used to. So I just went quickly to the Government of Canada website. There's a link in this last paper, in this last article. If you just Google the title, that you can go into the article and get the link, get this link. So here's the annual temperature change in Canada from 1948 to 2021. You can see there's a lot of variation, but the trend is, you know, 2021 was 2.1 degrees Celsius above the 1961 to 1990 reference value. From 1948 to 2021, the trend in average annual temperature departure, so the slope's gone up 1.9 degrees Celsius. Okay, and you can also look at the seasonal changes. So these are, winter, big rise in winter, less in the other seasons. So, you know, winter in Canada, the national seasonal average temperature over the 1948 to 2021 period, you know, and this is true in any northern country. Okay, the farther north, the further, the higher the anomalies. So winters increase 3.5 Celsius. Spring, summer, and autumn between 1.5 and 1.8 Celsius. Okay, so there's a huge regional difference. Part of it, the reason is in the winter, there's the snow cover, there's less snow cover, so we're going to get higher albedo. There's less radiation being reflected back into space from the snow covering the Earth, snow and ice. And then you can do regional. So this is the temperature. Now, this is only from 1961 to 1990, the reference period. They should have it from 1948 to now, but they've changed it, but they don't. So you can still see from this climatological average over this 30-year period. This is to 2021, the warming. So huge warming as you go further north in Canada. There's some moderation around Hudson's Bay. So the warming is most significant in eastern Canada and in northern Canada. So this is, Western Canada, less warming. And, over here on the coast, in fact, not so much. But up here in the far north, we're talking about, orange to red, so 3.5 to say 5.5 degrees Celsius warming since, a fairly recent climatological average. Okay, so what else do we show about the indicators? There's a lot of climate data on Canada here, and it's from, gridded data. It's, hybrids between data and models, and so on. And there's references here for papers specifically on changing climate in Canada. So getting back to the world situation, here's the UN has forecasted a 2 in 3 chance of briefly hitting the key heat limit of 1.5 Celsius within the next 5 years. So 2 out of 3 chance. And I'll show you this link gives you the report, the report summary. Okay, so it talks about the guardrail. It says that, we won't stay above 1.5, but we'll surpass it with the peak of the El Nino, and then probably drop below it, and then surpass it for good with a few years after that. Okay, so this statement, the media really emphasizes, climate scientists said what's likely to happen in the next 5 years isn't the same as failing the global goal, the 1.5 goal. Well, that's a bit crazy, that statement, because, it'll be exceeded within a couple of years after you exceed it once with the El Nino, if you just look at the graph, the trends of the graph. Okay, a single year doesn't really mean anything. Well, yeah, you can say that if you want, but the single years are trending up and up and up. So of course they mean a lot. It says it doesn't mean much relative to a 30-year average. Well, this is baloney, like I'm saying. The 2/3 or 66% odds of a single year hitting the 1.5 threshold within 5 years. It was 48% last year. Okay, it was 40% the year before, 20% in 2020, and 10% about a decade ago. Well, it's 2/3 now. It's up to 2/3. Yeah, so here's, there's climate stress everywhere. Lakes drying out, reservoirs drying out, access to fresh water, a problem. It talks about the graph a little bit, like the La Niña somewhat flattened the trend of human-caused warming. Again, we can go back to the original image here. So this has been El Nino years, or La Niña years, for 3 years in a row, which has kind of flattened this out. But now, we're going to shoot out of that. Okay, basically. Okay, that's what they're talking about there. And, they get a few Michael Mann quotes, of course. Okay, so here's the WMO website. And this was just published a couple days ago, so and this is the source where all of the the Guardian and all of the world media organizations basically pulled and put together stories based from this page and from the original report. So I'll show you the update. I keep drilling deeper and deeper till I get to the source. So again, a 2/3 likelihood that the average annual near-surface global temperature between 2023 and 2027 will be more than 1.5 Celsius above pre-industrial levels for at least 1 year. Now they say 66%, right? It's really 66.6%, which rounds up to 67. So I don't know why, this is just, should be 67, right? We know how to round up they truncate it instead of rounding up. Always trying to make things look slightly better than they really are. There's a 98% likelihood that at least one of the next 5 years and the 5-year period as a whole will be the warmest on record. Okay, again, they say this report doesn't mean that we'll permanently exceed the level. We'll cross the level and then we'll breach it on a temporary basis with increasing frequency for probably just a year or two. Okay, there's only there's a 1 in 3 chance. That should be 33.3%. They've rounded it down to 32. There's only a 32, 1/3 chance that the 5-year mean will exceed the 1.5 C threshold. Okay, so the next 5-year, the mean can exceed the threshold, right? So we could have years up to 1.8, basically, 1.7, 1.6, the average being over 1.5. That's with a 1/3 chance. Okay, and then the key points, the global average temperature in 2022 was about 1.15 above the 1850 to 1900 average. I argue if you take that relative to the 1750, the original pre-industrial baseline, you need to add 0.2 or 0.3 to that. So you'd be 1.35 Celsius to 1.45 Celsius. Okay, La Niña, the last 3 years, it's temporarily reined in the longer-term warming trend because more heat is being captured in the deep ocean and it's not being expressed in surface temperatures. But the heat is now coming out and we'll be doing that over the next few years. So we're supposed to be between 1.1 and 1.8 Celsius higher than the 1850 to 1900 average between 2023 and 2027. Okay, so, the average of this could be over 1.5 with a 1/3 chance. There's a 98% chance of at least one of the next 5 years beating the temperature record set in 2016 when there was an exceptionally strong El Nino. So we'll go back to this. That's beating this curve, this peak here. Okay, Arctic warming is disproportionately high, right? They talk about 3 times as large, but depends on what you define as the Arctic. If you go to the further up into the Arctic you go, this 3 times is maybe the average, becomes 5 times, 6 times, 7 times, 8 times in the high north. Okay, increased rainfall in the Sahel Desert, northern Europe, Alaska, and northern Siberia. Well, it could be snow in Alaska and northern Siberia. Reduced rainfall in the Amazon and parts of Australia. These are typical El Nino situations. So again, less rainfall in the Amazon is going to be catastrophic to its ability to absorb carbon. Okay, and then there's some maps showing the anomalies. This is May, June, July, August, September, summer versus winter. November, December, January, February, March, the anomalies. So look at the huge warming in the Arctic, approach above 3 degrees Celsius warming. And okay, so that's that article. And now, okay, so this guy here, this is, I think I've shown you this. Yeah, I've shown you this sort of thing. It looks like a duplicate. Okay, so this is the WMO report, okay, which is linked to in the articles that I've shown you. they call it the WMO Global Annual to Decadal Climate Update. And they actually look at 2023. They also look at the 5-year period 2023 to 2027. Okay, and so this is the PDF of the report, 24 pages long. If you want to get all the details, you can look here. I've talked about most of the things that you see in here. The ENSO, El Niño Southern Oscillation, the La Niña, is predicted to be most likely positive in December to February. So December 2023, January, February, that's when it's going to be the strongest. But it could last for several years. We don't know. It's going to likely be a super El Nino blowing away global average temperatures. Because of the heat has been stored for the last three years. So there's some discrepancy between the 66% number and the 98% number in news reports, but basically the 66% or 2/3 is a chance of global near surface temperature exceeding 1.5 degrees Celsius above, they say pre-industrial levels, but they define that as the 1850 to 1900 average. And that will happen for at least 1 year between 2023 and 2027 with a 2/3 chance. A 1/3 chance that the 5-year mean between these years will exceed 1.5. And the chance of at least 1 year exceeding the warmest year on record, 2016, is like 98%. Okay, and I've shown you the graph exceeding the peak, basically. And they talk about reduced rainfall in parts of Indonesia, the Amazon, Central America, and above average rainfall in the Sahel, Northern Europe, Alaska, and Northern Siberia. Reduced rainfall for this season over the Amazon and parts of Australia. Okay, now they reference this report, which is a much more extensive report, the WMO State of the Global Climate Report. I might do a separate video on that. So this report just shows things I've already talked about, but here they give the anomalies from 1991 to 2020, the most recent 30-year period ending on an even decade. Right? So even if you compare what happened in 2022 to this average, you still get significant warming. This is the, near surface temperature warming. Okay, this is for 2022. This is 2018 to 2022. The 2 years bracketing the 2020, which is the high end of the climatological, right? I mean, you can pick, why don't they take the compare 2022 to the 1993 to 2022 climatology, right? You can play around with the baselines and always, you always be aware of what this baseline is. What are they comparing to? Because, that's the key thing. And here's precipitation. It's kind of looks like a bit like popcorn, more in some areas, less in other areas. There are some trends here, drying in certain regions and, more rainfall in other regions. So there's some trends that are sticking out there. Anyway, I'll let you have a look at and then they do it by months. I'll let you go through and look at the details. This is the anomaly. I mean, they're using, like I said, a really recent climatological baseline. And then they give the probabilities, forecast probabilities, try to assess, if they're forecasting on ENSOs is accurate and so on. Okay, I mean, there's plots like this. This is a probability of above average near surface temperature. In this, these years. So for May, June, July, August, September, 2023 to 2027, right? So, most areas are, very high probability of being above average. And they probably do this for, the next one is probably for the winter. And there's just some statistical stuff. Okay. Anyway, I'm not going to go into all of the details. I've talked about most of the key things that have come out. I do want to just show you. This is I'm looking at the state of the climate report, and this is something I should probably go through in great detail. It's a good overall summary of where we were in 2022, and I don't think I've covered this in a video when this article first came out. I'm not sure exactly. It doesn't say the date it was published, but this is 6 different groups around the world, and their global temperature analysis here. And again, you can see, the very strong peak here, the El Nino in 2016. So 98% chance we're going to surpass that in the next 5-year period. And a 2/3 chance we're going to pass the 1.5, which is off the top of the scale here in the next five-year period. You can also see the 1998, this peak here was a very strong El Nino. So, it'll jump above 1.5, but probably come back down, and it might take just, 2 years, maybe 3 years to come back and surpass the peak. Unless that didn't happen after this El Nino because of the cooling, the 3 years of La Nina. But if there's not 3 years of La Nina, if it goes neutral or something, then you can pass that peak very quickly a few years later. So that's what we're looking at. This picture is from this, the WMO report called State of the Global Climate in 2022. These things, they usually take, a few months, sometimes a third of a year, or even half a year to come up with this report in the following year. So, I don't know when this report was published. I wish there was a date, but I couldn't see it. They just say copyright 2023, the World Meteorological Organization. But this report, I'm going to go through the highlights and, the figures. Like, these are the greenhouse gases, for example. I mean, look at the methane growth rate since 2020. Like, it's scary. It's approaching, it's on a spike upwards. Nitrous oxide growth rate, CO2 growth rates, everything's trending up. All of these, here's the curves here. I mean, look at this big spike here. Everything's trending up the wrong way, and we're still funding fossil fuel industry to the tune of billions upon billions of dollars. And these, we're basically trashing our planet's climate, shooting ourselves in the foot. So I think this is, this article, this report, I'll do a separate video on it. So thank you for listening. Please check out my paulbeckwith.net, my blog, and please consider donating to my PayPal account to support my research and videos. I've had a little bit of a gap. The last week or so, I've been really boning up and studying a couple different papers, and I'll just give you a little highlight. So James Hansen, there's a lot more warming in the pipeline, was an article, and then his website. And this is the article, Global Warming in the Pipeline. I'm going to focus on this very soon in a video, but it's a very involved paper, shall we say, and I want to cover it in detail to let you know. There's a lot of math, there's a lot of calculations and plots and stuff, and he's following up this paper with one called Global Sea Level in the Pipeline. So it's what we're committed to. It's not, pipeline is just a metaphor. It's what's coming down in the near future. So I think I'll do this for my next video. So thanks again for listening. Please consider, please check out my Facebook page, facebook.com, paul.beckwith.9/ or just look for Paul Beckwith. I've got a page, and I've got my personal page and another page, a group. My Twitter, Paul H. Beckwith. I also post on LinkedIn. I post on Instagram. I post on on Quora, and I also post on Reddit in the Reddit/climate subreddit. And I need to still, do it with Mastodon and Telegraph and, any others that I can think of. So if you have a list of social media sites that are a must, probably TikTok too, although that's being banned in some places. But anyway, thanks for listening, and, buckle up. It's going to be a very warm, the next 5 years is going to be an eye-opener for the power of climate, how quickly it's changing, and how devastating it can be to people's lives around the planet. Not equally, of course. Depends on your luck in the climate casino, right? Some people are very lucky in the climate casino and they get their houses flooded out, or tornadoes, etc. Tropical storms, droughts. It's like the consequences from abrupt climate system change are very uneven around the world, as you know. Okay, well, thanks for listening, and we'll chat soon. Bye for now.